Hey guys, welcome to my YouTube channel. I solve LeetCode 75 questions using Go programming. So let's look at today's question. Product of array except self. This is a very popular question. As you can see, Uber has literally asked it 21 times in the past 3 months. So it's a quite popular question. So let's look at it. Given an integer array nums, return an array answer such that answer of I is equal to the product of all the elements of num except nums of I. The product of any prefix or suffix of nums is guaranteed to fit in 32-bit integer. You must write an algorithm that runs in O of n time without using division operator. Okay, so basically what the question is telling, let's understand the question first. You're given an array like this. So basically for the first element, if I is 0, for this, what is the product of element except this? So it is 2, 3, 4. 2 into 3 is 6. 6 4s are 24. What is it for 2? It is 3 into 4, 12. 12 into 1, 1. 12, sorry, 12. And what is it for this position? 4 into 2, 8. 8 into 1, 8. And what is it for this position? 3 2s are 6. So this is the answer they're expecting. So the expectation is fairly straightforward. So you just have to compute the product of every other element except that specific index. How would you do it brute force? For brute force, I think you would just go from I is equal to 1 to n. Again for j is equal to, for I is equal to, you would go from 1 to n. For j, again you would go from 1 to n. And if I is not equal to j, you would sort of find the product. So basically for this index 3, you would go through all the elements, and if it is not equal to the position I, you would just compute the product and append it to the answer array. So doing like this, you would have still gotten the answer, right answer, but you would have taken n square. But they're specifically telling us don't do it in n square. You need O of n time complexity. And also, if you had to use division, how would you use it? What you would do is you would sort of find the product of the entire array, and then you would go to each position and divide that value at that position. You would still get the answer. It would be O of n also, but they have specifically told don't use division operator. So ruling both of these out, how would we do it? So the one approach is, see, like if this is the array, like what do you need? Like if I is here, you need to know what is the product till this point and what is the product after this point. So you need to know the product of all the prefixes, product of all the suffixes. I hope you guys are familiar with prefix sum concept and suffix sum concept. If not, I'll just give you a brief walkthrough of what it is. Prefix sum mainly is to find sum till I minus 1th position. So basically the way it would work is prefix sum for the 0th position is 0 because nothing is there to the left of it, and till the position 1, which is 2, is 1 because 1 till at this point. For position 3 it is 2 plus 1 3, and for position this it is 3 plus 2 plus 1, that is 3 plus 2 is 5 plus 1 6. So this is prefix sum. And what would be the suffix sum? For this position, it is nothing is there to the right, so just take it 0. And for the 3 it is 4 because 4 is there to the right of it. And for position 2 it is 3 plus 4 7. And for position 1 it is 2 plus 3 plus 4, that is 7 plus 2 9. This is the suffix sum. So this is, I hope you understood this concept. Prefix sum, suffix sum. But we won't be using sum in this problem because it mainly involves product. But we'll be using a similar product, but instead of computing sum, we'll be computing product. So what is the prefix multiple, let's call it, for this? For the first position, let's consider it as 1 because nothing is to the left of it. For the second position, it is 1 because 1 is there. For the third position, it is 2 into 1 because 2 and 1 is there before. Product of 2 into 1 is 1. For the last position, it is 3 into 2, that is 6 into 1, 6. This is the prefix multiple answer. Similarly, you can also calculate suffix multiple. Right, so how do we calculate that? For 4, let's consider it as 1. We are coming from right to left here. For 3, it is 4. And for 2, it is 3 4s are 12. And for 1, it is 2 3s are 6, 6 4s are 24. Now, how would we get the answer? Answer would be fairly straightforward. Just multiply these two. That is 24 into 1, 24, 12 into 1, 12, 4 2s are 8, 6 1s are 6. Did we get the answer? 21, 12, 8, 6. So we got the answer. But this is taking up extra space, right? You're having like a prefix multiple array, you're having like a suffix multiple array, and then you're computing the answer. That's too much extra space. So what I propose is, let's do it in O of 1 space. That will be like more efficient. So to do that, let's compute prefix multiple as it is, but we'll call it answer. Because if you see the follow-up they have told, can you do it in O of 1 space? The output array does not count as extra space. So if the output array is answer, they won't count it as extra space. So prefix multiple only, I am calling it as answer. Now I want to avoid calculating suffix sum and sort of do it directly so that I am not using extra space. How can I do that? So let me just, instead of having a suffix multiple, I'll just have a variable, right, which is initially initialized to 1. So the same answer, let's vary it. Let's vary the same answer. Okay, initially multiply answer with right. 6 into 1, that is 6. So we got the answer to the last position, 6. Now multiply right with element which is at that position, which is 4. 1 into 4, 4. Now again 2 into 4, 8. So we got the answer for that position, 8. Now multiply 4 with 3, that is 12. Again 1 into 12, 12. And then multiply with that position, 24. And then multiply 1 into 24, which is 24. So you completely eliminated suffix array. You just had one variable right, and then you got to find the answer. And since they told your answer array won't be counted as extra space, we technically did it in O of 1 space. I know like it is difficult to understand this logic, what I did here. So let me write out the code. I think when you see the code, you will understand it in a but much more better manner. So let's jump into the code. So what is the first step? First step, declare answer slice and any initialization if it is there. Let's do it. I'm calling it answer because as I mentioned it to you, I'm calling prefix multiple array as the answer. And then do the suffix logic, and then whatever the return logic is there, we'll do it. So let's calculate length and call it n. Okay, and then let's calculate answer. Make, we may use make to initialize memory for slice or any other data structure in Go. So make initialize me as slice, and it will hold int. So it will hold int and give me a size of n. So this is how you do it. And then let's do the suffix. Yeah, I still have to compute the prefix. So compute prefix. How would we do it? The first position doesn't have anything on the left, so call it 1, and then for I is equal to 1, second position, I is less than n, I plus plus. Take this loop, num of I, answer of I is equal to answer of I minus 1 into nums of I minus 1, nums of I minus 1. So this basically give you the prefix multiple array. So once you have this, initialize write, because we don't want to do the suffix array logic, extra space we don't want. Initialize the write to 1, and then again create a loop. This time we are going from I n minus 1 to 0. We are going backward, right to left we are going. Answer of I, multiply it by right. So this basically means answer of I is equal to answer of I into right. This is like a shorter way of writing it. And then update right. Right is equal to right into nums of I. Okay, then you just return answer, because answer is already computed when you do this. So let me just summarize the code. This is just basic initialization, and here you are computing the prefix as I had explained it to you. This is the prefix computation logic. This is the suffix computation logic. So answer of I is equal to answer of I into right will sort of give you the right answers at that position, and you keep updating right, and then you return it. So let's see. Yeah, it works. Why is the runtime it's still not that great? The time and space, let's compute and let's argue about it later. The time complexity is you're going from 1 to n and then 1 to n. Time complexity is just O of n in this case, and that's the hard requirement for this problem. And space, we made it O of 1, right? Because we ignored using the extra suffix array, we made it O of 1. This is a very optimal solution. Is there any way we could have made it better? We are using make, pre-computing, post-computing using suffix. Yeah, I think it's a fairly good solution. And yeah, that's it for today's videos, guys. Thank you so much for watching. Hope to see you in the next video. Bye.